guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. It's the wee hours of the morning. And I mean the wee hours of the morning. I just had to take the whole foot of this camera apart so I could mount it to the tripod. And the mount for the tripod, the plastic's breaking out on the bottom of it. Sorry, these little things drive me crazy. I go to set this thing down on the workbench and it wouldn't even sit on the table level because somebody's ripped the rubber foot off the bottom of it. So I went and I took one of my standard rubber feet and sanded it down so it's the same height as these other four. So at least when we're done doing what we're doing here, we can give it back to the guy and say, hey, look, here, it doesn't flop all over the damn place. Okay, so what we got here is the Boomer Deluxe, believe it or not. This is a Power Deluxe, but this is made by Palomar, the same guys that were making Palomar with the same parts. There's been so many different companies making Palomar. And the guy that quote-unquote owns the rights to these and so on and so on and so on. It's a long, convoluted story that we're not going to get into here today. But needless to say, this is the Boomer Deluxe, like 350 or 400, with the 35 amp regulated supply built into it. Now this is for my friend Charlie, my good friend Charlie. Comes every one of my brakes and is what I call a transporter. He's a friend of mine. He's kind enough to transport things from the Northwest because that's where he drives truck through. So he dropped this off a few months back, and what we have to do today is I got to replace these bridges. So they're completely burnt up, these rectifier units. They mount back here on the back corner of the wall. So, now that I got my parts out of it, let's very carefully slide this over here, because it's only being held together with a couple screws. And let's see if we can figure out the best way to get this little mammer jammer apart, because everything's soldered. And it's through holes soldered. So I think my first and best thing is going to be to file off these fins. So let me go hit this with the sander. We'll get this cleaned up real quick and then we'll start taking it apart. So I'm probably going to need this. Now, the reason I got to sand those legs off is for any of you guys that have ever done one of these, you know there's going to be a lot of prying and pulling and pushing that's involved here. And the least amount of distance I got to move the board, the better I'm going to be. So now what I'm using is my hot air induction iron. And this is just blowing hot air down on the traces. And we're going to let the heat sink through the trace. You got to be careful because this hot air induction will get hot enough to burn this board. Don't you love how it makes my lights blink? So my buddy Charlie is coming through here in the next couple days. And I want to make sure to have this thing very well tested and ready to go for him by the time he gets here. Whew, sucker's hot. The one, there's two. Oh, nope. Nope. Ah, damn. Man, that baby is hot. Okay. Well, I'm going to have to use a different iron, and it wasn't plugged in, so hold on a minute. Okay, there's one. Hot son of a gun. Okay. There's two. There's two. Wow. So it has come to my attention that this isn't the first time this has been done. I think this amp originally came from Brian Smith. And this is a dual-sided board. So we're going to modify the way this is mounted to make it a little bit easier in the future if this ever needs to be changed out again. But I think now that my buddy Charlie has got his head wrapped around how this works, I don't think that we'll be back here anytime in the near future. There we go. What I mean by modify it is we are going to make it so that the diode bridges sit farther off the board. We're not going to put the board all the way down on them like these were mounted way down. We don't want to have that happen again. So if I've got to come back in here and do something in the future, it makes it a little bit easier to unsolder it. That, and it allows us to be able to visually inspect. Yeah, I'm going to have to go back and solder the other sides. When I went to buy these 50 amp little diode bridges, I haven't used these for, God, probably 4 or 5 years now. I used to use them in everything because, you know, the big guys, they used them in everything. And I had so many failures with these little bridges. I don't use them for anything anymore. So I had to order these, and I had to get these actually out of Europe. I was having a hard time finding them here in the United States a couple months ago when he dropped this amp off to get it redone. He goes, I don't know, it just quit. And the rectifiers all seem to be cool. Everything seemed to be cool, except for I wasn't getting anything out of the rectification ring, this thing. So, and what I need to do is utilize that surface area on both sides So slide some slobber in over here. Slide some slobber in over here. There we go. Okay, got the magical pixie glue in place. All right, let's take the rest of this apart and test it. Okay, now we got our magic pixie compound on here. Get this first one started. And what I mean by magic pixie compound is a white thermal conductive silicone based compound. Heat conductive cream. There it goes. We'll get this bolted down good and tight. Now, all we should have to do is that these were clipped before. These would clip down onto the legs of the diodes. But I've made an executive decision to skip around that connection and go directly to an actual fully functional electrical connection, other than just a sheer mechanical connection. Translation, we're going to solder the legs in place. Come on. Okay. That looks good. Okay. Oh. Wow, that would have been catastrophically bad. I almost soldered the wrong thing to the wrong post. I got to thinking about it and I'm like, wait a minute. Okay. Hot. Okay, so now all the tabs have been The wires go into the plugs have been soldered. The plugs have been soldered to the board. And the board has been soldered to the bridge rectifiers. Go ahead and button this back up and make it run. Pretty sure that's all that's wrong. Taking into account, usually when something goes bad over here in this section of the power supply, it's usually fairly catastrophic, and this thing is beyond minty clean. I don't like that. I don't like that. I don't like loose, flappy parts. It could have been hanging out there for 20 years like that. I touch it. 2 weeks from now, Charlie will be calling me saying, well, it blew up again, and I think it was this capacitor that was just flopping around in here. You know, it's just my luck. So I'll take a hot New York second here. Put down some super sticky double-sided stick tape. Now, 3M, by the way, or Scotch. This particular brand is Scotch, but I use Scotch or 3M. There's two reasons behind that. If I was to use like hot glue or any other kind of glue substance, it would degrade. And over time, we found that most of those kind of glues actually end up conducting after age takes effect on them. The other thing is you don't want to have the capacitor directly coupled to the heatsink, because then you'll have heat transfer, where the double-sided stick tape allows us to have a little bit of an insulating barrier for the heat. Kind of acts like a heat membrane. It's got a very low, I guess if it had a dielectric principle to it, it'd be very low in conducting heat. I think would be the best way to put it. So let's put this thing back together, and we'll see what happens here. We'll just hit it and quit it. We'll just be brutal about it, right? No, I'll use a variac. We'll be back. And let's see what we got here. I know the bridge is what was faulty because I've already tested this, but I'm testing this for your visual knowledge. We've got this on diode check. And that should not be shorted. That's not an open, but that's an open. So you have a short going from here to here, from here to here, and here to here. Not cool. So no short from positive to negative, no short from positive to negative, no short from positive to AC. We'll go AC to nope, 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 nope. Actually, I have no conductivity in any direction. So we got 2 diodes out of the 4 that are good and 2 that are open. So let's throw that in the FU bucket. Okay. Let's go over here to volt. Everything's in frame. Amy figured out how to do something right. Okay, we got that in the on position. I can hear it humming already. So transformer's in there fluxing, and the regulator circuit did its job. 14.47 volts output now. We had 0 before. That means amp is going to work. At least the lights are going to work. Okay, cool. Well, let's actually test the amp now. Cool. I dig it. Okay. 1,000 watt slug and peak, 1,000 an average, 5 watt slug and reverse. Back from the L-Bird 10,000 watt dummy load. See if I can keep from stuffing my finger in the screen. Oh, in the fan, I mean, because there is no screen. Alright, amp off. Hello. Hello. Pass through looks good. Hello. It's 400 watts on medium. Let's go to low. Hello. 200 watts on low. Hello, 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 hello. It's good on the spectrum analyzer. Hello. 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 Made about 450 watts peak. Not teabag. Not teabag at all. So let me zoom in here for you guys. Okay, like I said, far right hand side over here, 1000 watt slug and peak. Hello, almost 500 watts. Spectrum analyzer. Hello, hello, hello. Hello, silly scope. Silly scope. 1, 2, 3, 4. Hello. Okay. Pew. Back over to here. Back down to low. Hello. Go to medium. Hello. Go to high. Hello. And this is the very first Palomar I've ever had come in here, ever, in all my years of doing this, where I didn't have to twiddly dink around with the input. Look at this. It's a 5 watt slug inverse between the radio and the amplifier. Hello. That's on high. That's a half a watt of reflect. It's more than acceptable. Here's medium. Hello. Hello. That's low. Now we know that most likely on low and medium you're going to have a good input tune, because we got it buried underneath a different level of resistors for each one of the settings. I put a little resistor in here as like a voltage divider. People call them attenuators. Really not. They're just a voltage divider that knocks the carrier back a little bit, knocks the input power back. So $200 watt solid dead carrier. Hello. 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 To revalidate the drive. We could talk through it with no reflect, which means we're going to be able to hear through it just fine. Power supply is working. Oh, there's one other thing I want to check. You can measure for AC leak in a power supply in multiple different ways. And for ease and expediency here, we're going to do it this way. Nothing. Absolutely nothing. Another way we can do it is we can go look at our waveform, our output waveform. That's clean. And where the AC leakage will show up in the power supply is going to be, this is touchscreen, so I got to be careful not to touch it. It'll be on the very upper edges. You'll see another second small little band of noise that'll be presented, and it'll be rippling. And we got nothing. And even according to the digital scales that we're all looking at right now, we got nothing. So we got no power supply leak. Means this capacitor bank is good. At least the filtration side of it, and the diodes aren't leaking because they're brand new. Well, here you go, Mr. Charlie. You're all set, my friend. Yet another one of your little projects brought back from the grave. And take it easy on this. You might want to think about getting yourself a little fan to move some air, especially across this side. This is where most of your heat's going to be. Every once in a while, Charlie, as you're talking on this, you might want to put your hand back here and fill this end of the heat sink. This is where your bridge rectifiers are at, now that you know that. All the regulators are mounted down this wall. But your 4 transistors over here, which are actual real deal Motorola's from back in the day, either 1446s or the small body 455s or 454s. They're about $100 and some a piece now. So, I mean, yeah, this is only a very small 35 amp regulated supply, but take care of these transistors that are in here. Of course, when they go up, we wouldn't replace them with the transistors that are in here. We'll put HG 2879s in there. The other thing is, the only thing that's regulated on this power supply is the output jacks on the front. The amplifier runs on an unregulated jumper joint, so they've got some wires that run right over here and they grab it right before it goes through the regulatory body, and it grabs at unregulated voltage. That way you can get a little bit more juice out of the final section. So on that note, I'm done. It is 5 o'clock in the morning. I'm going to slap this video together real quick and get it set off to YouTube. I'm going to go to bed. I'm going to go sleep for another 3-4 hours and get up and do this all over again. So on that note, gentlemen, my name is BBI, and without a shadow of a doubt, I am the biggest mud duck in Idaho. I appreciate you all tuning in to check out this little talk show about the Power Deluxe 35. Model 35A. As so indicated, right? Down here. I'll take a quick photo of this. Guys, I appreciate you all tuning in, checking it out. Quick, easy repair from my good friend Charlie. I'll see you guys. Bump, bump.